Welcome back to the channel. Today, we're diving into a robot unlike anything you've seen before, one that doesn't just think fast, it thinks everywhere. If you're into cutting-edge AI and robotics, you're going to want to see this. Let's get into it. What if I told you there's a robot with 100 brains? Not one big central computer, but tiny, fast-thinking minds spread across its body. Each finger, joint, and patch of skin can sense, decide, and act in real time. This isn't science fiction, it's Pi 0.5, the latest breakthrough in robotics. A machine that doesn't just follow orders, it thinks for itself instantly. From cleaning your kitchen to folding laundry while dodging a human elbow, this AI doesn't just react. It adapts, learns, and keeps moving, no Wi-Fi required. Welcome to the future of robotics. This is the AI robot with 100 brains that thinks and acts instantly. Imagine a robot where every part of its body has its own brain. That's exactly what Pi 0.5 introduces, a radical shift from traditional robotics. Instead of one central processor controlling everything, Pi 0.5 uses a network of tiny neural modules called Pi nodes, distributed all over its body. Each of these nodes is like a mini brain. There's one in the fingertip, one in the elbow, even soft silicone patches have one. And each node comes with its own sensors, a micro neural network, and actuators. That means every movement, every adjustment, every reflex happens locally and instantly right where it's needed. No waiting for instructions from a central server. These nodes operate independently, making real-time decisions based on what they feel or sense. After every tiny movement, the node checks, did that improve grip? Did that reduce tension? If not, it immediately adjusts. The result? Robots that are incredibly responsive. In one test, a soft robotic gripper using Pi nodes improved grip accuracy by 30% and used 25% less power. No lag, no signal delays, just pure reflex. And because the intelligence is built directly into the hardware, it even works on ultra-low power chips like an ESP32. You could literally run one of these nodes off a coin cell battery. This isn't just faster, it's smarter. It means robots can adapt to real-world chaos, things like slippery dishes, shifting laundry, or surprise bumps without calling home for help. This is edge intelligence in action. Reflexes redefined. And it's just the beginning. If the reflex nodes are the robot's muscles and nerves, then the upper-level Pi 0.5 brain is its mind, its intelligence, its ability to reason and make sense of the world. This higher brain is something called a Vision Language Action Model, or VLA. It's a fusion of computer vision, natural language understanding, and motor planning all in one. It doesn't just follow rigid commands, it understands instructions and decides what to do, even in completely new environments. Most robots fail when conditions change. Same table, same lighting, same items fine. But move a chair or swap a spoon for a fork? They freeze. Pi 0.5 is different. It was trained using over 400 hours of real-world footage in real homes, doing real tasks. Robots bumping into chairs, grabbing oddly shaped pans, wiping tables, scooping toys, it saw it all. They added even more: static images of dozens of homes, robotic arms without wheels, object detection challenges, and humans giving step-by-step verbal instructions. The result is a Frankenstein-level curriculum that teaches the robot everything from what's a pillow to how hard should I grip a ceramic plate. The diversity in training made Pi 0.5 incredibly adaptable. In familiar environments, it had an 86% success rate in understanding language and an 83% task completion rate. But here's the shocker: when tested in a totally new home, with new lighting and new objects, it still scored a 94% success rate. That's nearly as good as if it had trained there. And when they removed the diverse training data, performance dropped dramatically. That proves one thing: diverse training isn't just helpful, it's essential. And the way Pi 0.5 thinks during operation? Even more impressive. When live, it doesn't just execute commands blindly. It thinks through every step. It starts with a high-level instruction like pick up the pillow. Then it breaks that down into a stream of joint movements, constantly updating and adjusting based on sensor feedback. And the genius part: the upper brain doesn't need to micromanage every movement. That's because the lower-level reflexes are so fast and reliable. The high-level brain focuses on strategy. The Pi nodes handle the action. It's like how your spinal cord keeps your balance while your brain plans your next move. That's exactly how Pi 0.5 works. Older robots had to choose between speed and intelligence. Pi 0.5 has both thanks to this two-layered brain system. It understands your words, sees your space, plans like a human, and reacts with robotic precision. It's not just a robot with a brain. It's a robot with a mind of its own. And here's where it truly becomes one intelligent system, a unified mind. Every second, the upper brain issues a command like grab the spoon by the handle and the lower nodes take over. The fingertips adjust grip. The arm joints check for resistance. If anything changes, a slip, a bump, the micro-brains react immediately. It's a division of labor that feels almost biological. One part thinks, the others act. Together, they adapt. And unlike slow, step-by-step planning robots, Pi 0.5 uses a method called flow matching. That means it creates a full-body motion trajectory in one shot, no delay, no hesitation. Just motion refined second by second. And it does this without needing the cloud or Wi-Fi. Intelligence is built in. Each node runs only what it needs. That means lower power, lower latency, and high responsiveness in messy, unpredictable environments. They tested it in strangers' apartments, no prep, no scans, no scripts. It wiped spills, made beds, scooped toys, and folded laundry. Even if someone bumped its arm mid-task, it just recomputed and kept going. It handled both clear and vague commands. Pick up the round brush, done. Clean the bedroom, it broke it into sub-goals like organizing, wiping, and decluttering. This is not the future of robots. This is the robot of the future. When we say Pi 0.5 has 100 brains, it's not just a metaphor. It's an entirely new architecture, reflexes in the body, reasoning in the mind, and a seamless connection between them. A robot that doesn't just execute, it understands, reacts, and improves. Pi 0.5 isn't one brain doing 1,000 things. It's 100 minds working as one. So what does this mean for us? It means the clunky, slow, overly scripted robots are on their way out. Pi 0.5 is a leap into a world where machines live with us in our chaos and actually thrive. This is no longer about robots following orders. It's about robots figuring it out on their own. Next time someone says AI can't handle the real world, show them Pi 0.5. Thanks for watching. If you found this as mind-blowing as we did, hit that like button. Subscribe for more deep dives into AI and robotics, and let us know in the comments, what would you do with a robot like this in your home? Until next time, stay curious.